Okay, let's look a little bit more closely at this substitution method for showing that an identity is true. Now, while you probably know the method, and it's quite simple in that all you need to do is to choose some appropriate values for a and x in our expansion, in our binomial, and then subsequently in the expansion of the binomial. And that in itself is a very simple technique. It becomes then a matter of, how do I know to use substitution? What is it about the identity that I can identify that leads me to know that I need to use substitution. Sometimes, especially in the textbook, they'll actually guide you into it. For those first few questions, they tell you what substitution to make. But unfortunately, in a HSC question, they rarely, if substitution is required, they rarely tell you that, one, you'll be needing to use a substitution, nor do they suggest what numbers you need to substitute. So for these questions, for any identity question really, your first step is to thoroughly analyse the identity and features of it, and really seemingly insignificant maybe features. And again, this is something that I'd encourage you to do as you answer each and every question. You'll probably at first just be trying to get them correct and work through the process that they're stepping out for you. But once you get the question finished, if you've got this running sheet beside you, like I'd suggested in the previous video, where you're going to actually now write down the identity, when you're writing that identity down, think about exactly what it looks like. Even, like I said, insignificant things like note the power here. Note if there's a similar power on the right-hand side. And just, I guess, as you're writing it, think about what you're writing. Are you writing coefficients? Are you writing an expansion? Have they written it in sigma notation? And ultimately, I guess, the purpose of the running sheet will be such that, because you'll have 3 categories of identities, you'll be looking for differences in the from one category to the next, or within a category you'll be looking for similarities. Now, I've tried for each one of these methods to identify for you a feature. Unfortunately, it has to be a little bit flexible. So for substitution, I've said many of the identities will simply just show the addition and subtraction of coefficients equaling a constant. So, but like I said, this is a very broad description, and you might actually find you'll come across an example of an identity, and it may not be exactly this situation. However, you will be showing it or proving it with a simple substitution. So just keep in mind, these are just this introduction of a feature, and trying to identify a feature. It's just something that I'm trying to do to help you to get these identities identified and put into a category. But please be a little bit flexible with this. Let's have a look. Like I said, hopefully you will end up doing that many questions that you yourself become very familiar with patterns, and you will know that because of the nature of the pattern, then it probably, and I'll just say probably, will be a substitution. And in the end, you will, like I said, have done enough that you will look at an identity and go, oh, that identity belongs to the calculus method, or that identity, no, it's a substitution, etc. And I put this one in because we have shown this one previously, and at times it comes up as a HSC question, which is a very easy mark, and I've not seen it being awarded anything more than 1 mark to show that this identity holds true, because it really is. It is something that we, because it's a very easily identified feature of Pascal's triangle. It's a very common identity that we are familiar with. And I think most students are introduced to this and have proved this very early on in the study of binomial theorem. Okay, so which particular feature of Pascal's triangle is it? Well, it's that the sum of the coefficients of a particular row is equal to 2 to the n. It's just equal to 2 to the n. Now, like I've said down here in the feature, it's the addition or subtraction of coefficients. Yes, that's pretty obvious that we've got the sum of coefficients, and it's equaling a constant. And how does this all fit our binomial? Well, actually, it's just the reverse of what we often start off writing. We often start off writing the binomial to the power then is n c. Hang on. Sorry about that. We often start off writing our binomial to the power and then show the expansion. But what's actually happened here now in the identity is this is the expansion with a substitution. This is the actual binomial to the power with the substitution having been made. So it's just the reverse of this. So this is in that spot, this is then moved to the left-hand side. Okay, so we look at the identity. We realise that, yes, how it's connected to a binomial, to a power and its expansion. And then we start thinking about, well, what has happened? And usually this constant is the best number to look at to give us an idea about what to substitute. And because we want to create a 2, which came from, remember, it came from the binomial to the power, then we can see if we simply put a is equal to 1 and x is equal to 1, then we'll get 1 plus 1 to the n. We'll have our 2 to the n. We'll have our right-hand side. And then we know if we put our a to the 1, x to the 1 into the right-hand side, then we simply get the sum of coefficients. Likewise, another feature of Pascal's triangle, and again, I have seen this to show this as a HSC question, which is again a very easy 1 mark. And I must say they're in HSCs from quite a time ago. It's not in the most recent HSCs that some of these easier identities were the question. Let's have a look, and yes, see what's really going on with either one of these. And this is where you'll see that you have to be flexible. Like I said, you have to actually be a little bit flexible, because we don't have, in this identity, we don't have the sum of coefficients. We have a single coefficient equaling a constant and a single coefficient equaling a constant. And so that's what I mean about, you've got to be a bit flexible with this feature, that not all the identities that will require substitution will actually look like this. It's just that a lot of them do. And again, this one we proved, I think, in probably the first or maybe the second exercise of the chapter. And we actually needed the combination of 2 binomials, one where we set a is 0 and x is 1, and then reversed that. X was 0 and a was 1. And yeah, we were able to show that identity using substitution. I'm going to stop it there and then do the U tries.